All right, so good morning. If there's anybody online, we're going to go back to the u-substitution stuff. Okay, so the first thing I wanted to do was let's work an example where we have a definite integral instead of an indefinite integral, and we need to do a substitution. Okay, so I'll do the example that's on page 3 here, which was 0 to 1 of x cubed 2x to the 4th plus 1 to the 10th dx. All right, so you got two options when you want to do a substitution that's it's on the table there, Suni. You got two options for what to do if it's a definite integral that's going to require substitution. One is just blow off the fact it's a definite integral and deal with that later. Okay, and usually that's the way I go. The second method is sort of deal with the problem as you go. And I'm going to show you guys the deal with the problem as you go because there are situations where that's the better way to approach it. Okay, maybe not so much in Calc 1, but like in multivariable calculus, then there are situations where that's actually a better approach. Okay. So the first question is, well, what substitution should we make? Right? And if we look at this integral, what we want to suss out is something whose derivative is what's left over. Okay, so any guesses? Yeah, okay, good. That'll redeem you for your tardiness, perhaps. Okay, so 2x to the 4th plus 1, because what's the derivative of that? Right? And then, so if I solve this for dx in terms of du, it'd be dx is du over 8x cubed. Okay, so we good with that? Okay, so now what? I want to start plugging things in. Okay, but I have to be careful because the numbers at the bottom and the top are in terms of x. Now, how do I know that? Because the thing was dx. Right? This might be helpful. This might be helpful. Okay. But if I'm switching things in terms of u, then the numbers that are at the bottom and the top need to be in terms of u. Okay, and it's not necessarily the case that they're going to be 0 and 1 again. Right? Just because x is 0 and 1 doesn't mean u is 0 and 1. Okay, the good news, though, is that we have a formula that converts between x's and u's. Okay, namely the substitution we picked. All right, so if x equals 0, then what do I get when I plug that into the u formula? I get 1 in this case. Okay, that's easy. Right? All right, what about if x is 1? 3. Okay, so all I'm doing, right, is plugging 0 or 1 into the 2x to the 4th plus 1 formula. So that's what I chose for my substitution. Okay? All right, does that make sense? Yeah? Okay, so now when I write the new integral, the new integral goes from 1 to 3 because it's going to be something, something, something du. Okay, so I've got x to the 3rd. What's the stuff that's inside the parentheses? What did I call that? Yeah, just u. And it's to the 10th. And dx was du over 8x cubed. Okay? All right, so there I just substituted everybody and put them in their appropriate places. Okay, so we're good with that step. And yeah, sorry, this may not perfectly match the blanks on the sheet there, but in order. Okay, so I've made the substitution, and now what? Does everything simplify correctly? Right, so by which I mean, when I cancel those x cubes, do I have anything left that's in terms of x? No, everything that's left is just in terms of u. Okay, so that's nice. That means that we've done the substitution correctly. All right, and so then what do we get? We get 1/8 u to the 10th du. Good? Okay. So what's the antiderivative of u to the 10th? That's a derivative, antiderivative. Right? So what do we got to do to the exponent? Add 1, so it'd be u to the 11th over 11. Yeah? Okay. And then what do I have to do with that 1/8? He just comes along for the ride. Okay. Do I have to write a plus c here? Why not? Yeah. So definite integral, you don't need the plus c because it'll just cancel out anyway, so why bother? Okay. All right. So I know it's 8 o'clock on Monday morning. U to the 10th, its derivative is 10u to the 9th. Its antiderivative is u to the 11th over 11. Okay. Yeah. And this is one reason why, historically speaking, so the idea of integration kind of is a little earlier in some sense than differentiation, although that's kind of a it's hard to pin these things down when they develop, the ideas develop over thousands of years. But that said, one of the things that makes integration tricky is that notice that we were also doing derivatives in the course of an integration problem, right? And so you got to be real careful to do the right thing at the right step. This is why you don't do calculus at 2 in the morning. You should be sleeping at 2 in the morning, because nothing good happens at 2 in the morning. Well, most of the time. Friday night, you can do whatever you want at 2 in the morning. But, yeah. Okay, so we got that. And then now, what do I need to do? Because this is a definite integral, I need to plug in the 1 and the 3. Right? Okay, so when I plug in 3, what do I get? Well, I have no idea what 3 to the 11th is, so I just get that. Okay, so 3 to the 11th is, of course, going to be a relatively large number. And then 1 is easy, but that's it. Okay? And so in this case, just leave it like that. If you wanted, I suppose you could put this together as one fraction, but since they already do have a common denominator, but whatever. Right? Okay, so question, preguntas, fragen. Okay, so what were the sort of 2 extra steps that we had to do here? We still had to do a u-substitution like we did last week, right? The 2 extra steps were we had to convert the bounds. Okay, so that's the stuff in red. And then because it was a definite integral, at the very end we had some number crunching to do. Okay, but otherwise not too horrible. Okay, now the other approach to this would have just been to pretend that it was an indefinite integral, done the problem like we did last week, and then do the number crunching. Okay, a lot of times that's the way I'll do it, partly because then I'm only doing one thing at a time, and I'm less likely to make a mistake if I'm juggling only one ball than if I'm trying to juggle 3. Okay, it doesn't matter, you'll get the same answer in the end, but being able to convert the bounds is kind of an important skill that may not be apparent now, but like I said, in the future it will be. Particularly for those of you guys who go on to Calc 2. Okay, which is going to be so much fun, right? Well, Ian, I've got good news for you. You know who's teaching Calc 2 in the fall? No, that's the good news. Is that you don't have to put up with me again. So, huh? Yeah, you have to put up with me, but yeah, I know, right? You're on your way to a minor in McKinney. Maybe we could get the registrar to let you guys declare that, and then be like, oh, you're a McKinney minor. You have to have McKinney on comms. And yeah, yeah. So, yeah. All right, good. So, right. So the other thing I wanted to do were a couple of spicy substitutions. Okay, and I'm just going to make one up. Well, actually, let me write two problems here. For sake of contrast. Okay, so the first one, where I've got the x minus 5 on top, we don't actually even need any substitutions or anything fancy here, because can I simplify the first one? Or rewrite it, maybe is another way of saying it. Yeah. How could I rewrite it? Right. I could just break it into two fractions, so common denominators in reverse. Okay. And what's the antiderivative of 1? X. Okay, that's easy. What's the antiderivative of 1 over x? And then, of course, our plus c. Okay. Now, remember, too, the absolute values, I'm not going to, crucify you guys over that, but it should technically be there. Yeah. Okay, so did we actually need a substitution technique there? No, we just were able to do it by simplifying a little bit first. Okay. The second problem, though, can I break that fraction up? Why not? I mean, because algebra or because math or, yeah, I mean, there's, how do you want to say it? But really the problem is that the difference, the x minus 5, is in the denominator, not the numerator. If it were in the numerator, like in the first problem, yeah, we could break that fraction into two pieces. But it ain't. So I'm kind of hosed. There's no no simplification that I could do to just make this problem go away. Right? So what do? Do we just throw up our hands and give up? Yeah? That sounds like something that the students at the alleged University of the South would do. Yeah, exactly. So we got to be clever. Okay? So, just humor me. Let's try this. Let's let u equal x minus 5. Well, it's not exactly all that clear how it's going to work out, because what's du then? In this case, du is just dx, right? All right, so if I substitute, then I'm going to have x du over u. Well, wait a minute. What's the problem? It's got an x, okay? And normally that is cause for panic. Okay, I claim in this case it isn't. So maybe stare at it for a second and see if you can figure out, huh, that's evil. I mean, this is maybe getting to the truffalo sauce level, right? It's a little spicy, but with a real hint of cleverness. Because who would have thought to put truffle with buffalo sauce? I mean, other than the folks in the B-dubs test kitchen. Once you guys see it, you're going to be like, oh. But until then, right? Okay, let's say what's happening there. All right, so let's go back to the equation that we used for a substitution. What's x? Yeah. We could solve that equation for x in terms of u, partly because it was a relatively simple one. Okay, now solving an equation, solving it the other way is not always easy, right? And in fact, sometimes there's not a single solution. Like the quadratic formula, for example, if you have y is equal to a quadratic, then x is going to be equal to, like, there's several answers, right? But here, the relationship between u and x is just linear, and so solving for x in terms of u is just as easy as solving for u in terms of x. Okay, and so what I can do is I can take this guy and plop him right there, and then I have u plus 5 over u du. And now there's no more x's. That's sneaky. Okay, so this is what I like to call a sneaky or flip-flop substitution, but it is not the sneakiest. Okay, there is a substitution that does lay the claim to being the world's sneakiest substitution. And Champ, you remember the tangent half-angle substitution? That's the sneakiest. Yeah. And I didn't make up sneakiest. Michael Spivak, who's a really famous mathematician, did. Yeah, that's probably my favorite substitution. My second favorite is when you say, oh, let me take this thing over into the complex plane and treat it as if it's a complex variable problem, and then do a bunch of voodoo, and just answers magically drop out. Okay. So u plus 5 over 5. Well, we're not finished. But does u plus 5 over 5 look a whole lot more workable than what we started with? Sorry, yeah. U, 5, same thing, right? Okay, why is that so nice? Because what can we do? Yeah. Just split the integral like we did before, or split the fraction like we did before. Okay, now it's a plus this time instead of a minus, but what's a minus sign amongst friends? Okay, so what do we got now? We have 1 plus 5 over u du, and that's going to be u, careful, plus 5 natural log of u plus c. Okay, and then we're almost done. Okay, so same split up trick like we did last time. And the same antiderivative. The only thing that changed here was it's a plus instead of a minus. Okay, big deal. Okay, final step. What should we do? Yeah, what was u? It was x minus 5. So I'm going to replace that. And I could write it that way, or let me write it one other way, and then you guys can ponder as to whether or not these are actually equal to each other. Where'd the 5 go? Being real sneaky. This is like when you got mashed potatoes and peas and you don't like peas, and so you're just going to hide the peas underneath the mashed potatoes. Did you guys ever do that when you were kids? No? You never did that, Ian? Because you like peas? Yeah, okay. All right, so where did the 5 go? He's there, he's just hidden. What is this? Right? What does plus C mean? It's some unknown constant. Well, what's minus 5 plus an unknown constant? Some other unknown constant. I don't know. Right? So I just sort of swept the constant part in with the plus C for tidiness. Okay? You don't have to do that, obviously, but I just wanted to point that little piece of trickery out, because you will run into it from time to time. Okay, so does that kind of make sense? So how do you know when you have to be kind of clever and do one of these reverse substitutions? Well, maybe the rule of thumb is try a non-clever substitution. Try just doing things normal, okay? And if that doesn't seem to work, no matter what substitution you make, and it's not something that you should have just memorized, excuse me, like arctangent or something like that, well, then maybe this is the approach you got to take. Okay? All right. So, for the rest of the time, what I'd like to do is, if you'll notice on pages 2, page 2, there's a whole bunch of problems. The bottom of page 3, there's a whole bunch of problems, 2 problems. I'd like to basically just, let's spend the rest of the time with you guys just working through them, okay? And so why don't we spend about, say 10 minutes or so working through some of them, and then I'll have some of you guys go to the board, which is something we haven't done yet this semester. And then we'll kind of talk them through, okay? Good? All right, so this is the crack the whip part of calculus. All right, so I'm going to quit the stream here because there's no need to stream you guys sitting around. And if you're online today, well, then guess you miss out on the fun. So.